Hi everybody, welcome back to my channel. In this video we are going to start working through the higher level core topics for the new IB Analysis and Approaches courses. So today we are going to be talking about straight lines. Let's begin. Okay, so here we have a graph. This here is the x-axis and this here is the y-axis here. And here we have a line, which I have labeled A. So firstly, before we begin this chapter, there are a few things that you need to know. The first one is the y-intercept. I'll just change the pen color here. 1 second. Alright, so this here, where this line cuts the y-axis, is called the y-intercept. Y-intercept. And the part where the line cuts the x-axis, which is this part here, that is known as the x-intercept. And then of course we have the gradient of the line. The gradient of the line I'm going to be representing with the letter M. So the gradient of the line is the change, which this sign is the delta. So the change in y divided by the change in x, and with y being the y coordinates and x being the x coordinates. So this can be written as y2 minus y1 divided by x2 minus x1, where x2, y2, and x1, y1 are 2 points on the line A. I should draw that out here. So this point 1 and point 2. So this we can say x1 comma y1, x2 comma y2. And the gradient is the change in y, so delta y divided by delta x. This here is the change in y, and this here is the change in x. And that gives us the value of m, and the gradient is basically this, it's a measure of the steepness of the line A. Alright, so we have all this sorted out. There are two more things you need to know before we begin. The first of which, I'll just change the pen color again, are parallel lines. Did I spell that right? Yes. Parallel lines. These are lines in which the gradients are the same. So if I have two gradients of line, so M1, this is the gradient of a line that we will call 1, is the same as the gradient of another line M2. And here these numbers are I'm just putting them there so that it's easier to differentiate between the gradients of two separate lines. And then perpendicular lines are lines that are 90 degrees to each other. So here, this is 90 degrees. So if two lines are perpendicular, then that means their gradients are negative reciprocals of each other. So what that means is that when you multiply them, M1 multiplied by M2, you should be getting -1. If this is true, then the two lines are perpendicular to each other. And here, with a little bit of rearranging, you can figure out what M1 or M2 is given one or the other. Okay, so now we will talk about the equation of a line. The equation of a line is just an equation which connects the x and the y values for every point on the line. So whenever you have a line, the x and the y values will always be connected with what is known as the equation of the line. There are a bunch of different ways to represent the equation of the line. So first and foremost, we have the point gradient form. The equation of any line written in the point gradient form is as such: y minus y1 equals m multiplied by x. Sorry, that's just how I write x. X minus x1. And here, x1 and y1 are just any points on the line. So this is really useful when you have to find the equation of the line, but you're only given one coordinate, say x1, y1. So here you can use this coordinate and get the equation of the line using the point gradient form. The next form we have is the gradient intercept form. This one is the one that we have been using since 8th grade, I think. And it is y equals mx plus c, where m is the gradient, as up here. M is the gradient, and c is the y-intercept. So I'll just write it here. M is the gradient, and c is the y-intercept. And finally, we have the general form. The equation of a line in the general form is as follows: ax plus by equals d, where a, b, and d are just constants, which means they're just numbers that don't change. So you can use any one of these equations to find an x and its a y and its respective x. For this course, you will also need to know how to graph a straight line. So firstly, we will learn how to graph a straight line using the gradient intercept form. Okay, so just a reminder, the gradient intercept form is y equals mx plus c, where m is the gradient and c is the y-intercept. So here is our first clue for graphing a line using the gradient intercept form. We know that c is the y-intercept. Okay, I'll just draw the axes here real quick. That's my bad. Here we have the x-axis, the y-axis. Okay, so now we know what the y-intercept is. So firstly, we will just plot a point at the y-intercept. Then we will use the gradient, and this is where the gradient comes in real helpful. As I mentioned before, m equals change in y divided by change in x. This can also be written as rise over run. Many of you might have seen this way of defining the gradient before. Right, so if the gradient is something like m equals 1 over 3, we know that the change in y is 1 for every 3 changes in x. So as x increases by 3, y increases by 1. So if we just move forward that x increases by 3, so this will be 3 here, y increases by 1. As x increases by 3, y increases by 1. So using this, we can, using the gradient, we can plot out where each point on the line will be. But because it's a line, any 2 points, just because we plotted 2 points, and using these 2 points, we can extend outwards, which will give us the entire line itself. Just remember this, as long as you have 2 points that are on the same line, you can just join them and extend them outwards, and that will give you the entire line itself. Okay, so now I will show you how to graph using the general form. As a reminder, the general form is written as ax plus by equals d, where a, b, and d are constants that do not change. Okay, so first, we will solve this by first letting x equals 0. So step 1 would be to put x as 0, And that would allow us to find the y-intercept, because when you rearrange this with x as being 0, you will have... Okay, so let's just move forward with ax plus by equals d, and x equals 0. So a times 0 plus by equals d. Anything times 0 is 0, so that just gives us by equals d. And now if we divide both sides by b, we get y equals d divided by b. And that is our y-intercept, the c, as I showed you before in the gradient intercept form. That is the y-intercept. Our second step would be finding the x-intercept by letting y equal 0. So by letting y equal 0. Again, we have ax plus by equals d. When we let y equal 0, ax plus b times 0 equals d. And because anything times 0 is still 0, we have ax equals d. We divide both sides by a. That's an a. We get x equals d divided by a. And that is the x-intercept. Okay, so now we have the y-intercept and the x-intercept. Our next step would be to just plot the points on the graph and join them together, because now we have 2 points. Here at the y-intercept, x would equal 0, and at the x-intercept, y equals 0. So you get 2 coordinates, 0, comma the y-intercept, and you get the x-intercept, comma 0. And here, if I was to quickly sketch this out, this is the x-axis, the y-axis. Okay, so we know the y-intercept. I'll just switch to another color for this. Okay, so we know the y-intercept here, and we know the x-intercept here. Here, so this point is here, 0, comma y-intercept at x equals 0, the value of y equals the y-intercept, and here, at when x equals x-intercept, y equals 0. And now we can just join these 2 lines, and that gives us, and that allows us to plot a graph using the general form. We just extend the lines in both the directions, and that is our line here. Now you may remember that at the start of the video I talked about 2 lines being perpendicular to each other. So if I have the gradient of line A and I multiply it with the gradient of line B, if these 2 lines are perpendicular to each other, I should get -1. And here I can just rearrange them to find either values given one of these values. And that allows us to introduce the idea of a perpendicular bisector. So the perpendicular bisector of a line segment, let's say of a line segment AB, is the line perpendicular to AB, so a line that is perpendicular to AB, but which passes through its midpoint. So let's say we have a finite line here, AB, and it's joined together by a straight line. The perpendicular bisector of AB would be a line that passes through the midpoint of AB, but is 90 degrees, is perpendicular to AB. So this would be the perpendicular bisector of AB because it's 90 degrees to AB and it passes through the midpoint of AB. Now, solving perpendicular bisector questions is not that hard. So the formula that you will require here is finding the midpoint of a line AB. So let's say A has the coordinates x1, y1, and B has the coordinates x2, y2. So the midpoint of these, so I'll just say mid of AB will be x1 plus x2, which is these 2 values here, divided by 2, and y1 plus y2 divided by 2. This will give me the coordinate for the midpoint of AB. So once I have the midpoint of AB, I can use these two lines to find the gradient of AB. So the gradient, so m of AB, is just change in y, so y2 minus y1 divided by change in x, x2 minus x1. That will give us the gradient of AB. So now we have the gradient of AB and we have the midpoint of AB. So about 2 minutes ago, I reminded you guys of how we had this formula, m1 times m2 is -1, right? With this here, we have the gradient of line AB. So if we substitute that in here, we should be able to find the gradient of the perpendicular bisector. So if we just put MAB here times M2 equals -1, and we divide both sides by the gradient of AB, that would give us M2, the gradient of the perpendicular bisector, would equal -1 divided by the gradient of AB. So at this point, we have the midpoint of AB, which is a coordinate x, y. We'll just call it x1, y1, because it will make it easier for you guys to understand what I'm talking about later on. So we have the midpoint of AB at coordinates x1, y1, and we have the gradient of the perpendicular bisector, M2, which we found out using this formula, M1 times M2 equals -1. So we have the gradient of the perpendicular bisector and the coordinates of a point that lies on the perpendicular bisector. And here we can just use this equation here, the point intercept equation. Here we can just use this equation, the point gradient equation. So y minus y1 equals m x minus x1, where m is the gradient of the line and x1 and x2 are 2 points that lie on this line. So now we have m2 here, and we have x1 and y1 from the midpoint of AB. So if we just substitute these values into this equation here, it should give us the equation for the perpendicular bisector of a line. Okay, so finally we have simultaneous equations. And there are 3 ways that you can solve simultaneous equations in this course. Firstly will be to graph the lines on the same set of axes, and the points at which they intersect will be the points where the simultaneous equation is solved. So for example, if I have an equation y equals x minus 3 and 2x plus 3y equals 16, if I graph these two on the same set of axes, which would be something like this, the point at which they intersect, its respective x and y coordinates, would be the solution to this set of simultaneous equations. Secondly, is you can use algebra or elimination to solve this, and using algebra, I'm pretty sure you guys might have done this before as well. So using algebra, okay, let's just begin by using elimination. By using the second way to solve this equation is by using substitution or elimination, and we just move forward with algebra. So here we know that y equals x minus 3, and if we substitute that in, this would give us an equation in just x, and we can solve that to get a value of x and then plug that in here to get a value of y, and that would just give us a solution to this set of equations as well. Lastly, you can solve this simultaneous equation using technology. So in this course, you are expected to have a graphics calculator, And if you just input these two equations into your graphics calculator, into the equation solver function, then it should return to you what the respective values of x and y are, which satisfy both of these equations. I will not be going over the graphics calculator instructions in this series. Thanks for watching this video. In the next video, I will be going over some sample problems from the straight lines topic, and I will show you how you have to expand and showcase your working in the final exam as well. If you have any questions regarding this video, feel free to leave them in the comments below and I will address them in the next video. As mentioned in my previous video, the two textbooks, which are linked below as well, are really helpful in learning this. So if you just want to move forward and learn these things by yourself as well, I would recommend getting those textbooks off of Amazon or whatever bookstore you use, because they are really helpful. The textbooks that I recommend for using in this course are linked in the description below, and I hope you stick with me until the next video. Thank you.